Alright, so this problem is just one quick example of how we can use the chain rule within an application problem. So here we want to find an equation of the tangent line to the graph of f of x is 2 sine x plus cosine of 2x at the point pi 1. Alright, so pi 1 is a point on this function. So if we want the equation of the tangent line, immediately we ought to be thinking derivative. So we need to find f prime of pi to get the slope of our line. Okay, so of course to get f prime of pi, we need f prime of x first. Alright, so we have the derivative of 2 sine of x, which is 2 times the cosine of x. And then we have this plus cosine of 2x. So there we have the chain rule that we're going to need to use. So first of all, the derivative of the outer function, which is cosine, is a negative sign. So I'm going to change that to minus sine of 2x. And then I need to multiply by the derivative of the inside, which is just a 2. Okay? So now we can find the slope of our tangent line by plugging in pi. 2 times the cosine of pi minus 2 times the sine of 2 pi. Well, thankfully the sine of 2 pi is 0, so that whole thing is 0. Cosine of pi is negative 1, so this is a slope of negative 2. And now we can use our point slope form or slope intercept form, whatever you want. I like to use point slope form, so here we'll go y minus 1 equals our slope negative 2 times x minus pi. I'm using the point pi 1 here. And then we distribute the negative 2, get the 1 on the other side, and we have in slope intercept form y equals a negative 2x plus 2 pi plus 1. So our y-intercept is 0, 2 pi plus 1. The slope is negative 2. There's the equation of our tangent line. Remember, if you're going to do that with decimals, which there's really no need to do, but if you do, make sure you give 3 decimal places. Alright, now our second example, determine the x values in the interval from 0 to 2 pi at which the graph of the function has a horizontal tangent. Right? Well, when you see horizontal tangent, you ought to automatically think, hey, the derivative has to equal 0. So we already have the derivative up there. It's 2 cosine x minus 2 times the sine of 2x. And that's going to equal 0. Now, here's where our memory of pre-calculus comes in handy. That sine of 2x, in order to solve this algebraically, we're going to need to use an identity. And I'm going to make that sine of 2x into a 2 sine cosine of x. So I already had a 2 out there. I bring another 2 out. That's 4 sine of x times cosine of x equals 0. Again, I'm using the identity sine of 2x equals 2 sine x cosine x, or double angle formula. And now I'm going to factor out a 2 cosine. So 2 cosine x times 1 minus 2 sine of x equals 0. And that means that either cosine x equals 0 or sine of x equals a positive 1/2. Alright, so the x values on the interval from 0 to 2 pi, cosine is 0 at pi over 2 and 3 pi over 2. Sine is a half at pi over 6 and 5 pi over 6. So there are 4 places in this interval where we have a horizontal tangent. And remember, that means these are either max points, min points, or points of inflection, or which we haven't gotten to yet, but plateau points. So not points of inflection, plateau points. And again, if we wanted to test that out, we would set up our number line with these in order. So the smallest would be pi over 6, then pi over 2, and then 5 pi over 6, and then 3 pi over 2. Okay, this is not what the problem was asking us to do, but just to help us kind of make the connection here of why we would want to figure this out. So now we're testing, we would test the derivative to see what sign it would have. So let's say I plug in, let's say I plug in a 0, or I guess I should use like a pi over 12 or something like that. Well, I know that for my derivative, 2 times the cosine of pi over 12 minus 2 times the sine of 2 times pi over 12, or pi over 6, we can figure out. Okay, so let's see, 2 cosine pi divided by 12 minus 2 times the sine of 2 times pi over 12, which is pi divided by 6. And that ends up being a positive 0.93185. All that we care about is the sign, which means our function f of x is increasing before we get there. Then, if we test something between pi over 6 and pi over 2, say a pi over 4, alright, 2 times cosine of pi over 4, which is root 2 over 2, so that's going to be a root 2. And then minus 2 times the sine of 2 times pi over 4. Well, that would be a pi over 2, and sine of pi over 2 is 1, so it's minus 2 times 1. So that's going to be negative, which means we're decreasing. Okay, so that means that pi over 6 is actually a max point, because we were increasing, now we're decreasing. We try something else in between pi over 2 and 5 pi over 6. Let's say we tried 3 pi over 4. We'd actually have the same thing that we did on the previous one, except it would be a negative pi over 2, because cosine's negative in the second quadrant. And then when we did sine of 2 times 3 pi over 4, that would be the sine of 6 pi over 4, or 3 pi over 2, which is a negative 1. So that would actually make this a plus 2. Okay, so that one would end up positive. Alright, so that means we have a minimum point at pi over 2. Then we have between 5 pi over 6 and 3 pi over 2. So we could actually do pi there. 2 times the cosine of pi is going to be a negative 2. Minus 2 times the sine of 2 pi. Sine of 2 pi is 0, so it's just negative 2 minus 0, which is negative. So there it's decreasing again, which means we had a max at 5 pi over 6. And then we try something after 3 pi over 2. Let's say we had a 7 pi over 4. Okay, we try a 7 pi over 4. It's between there and the 2 pi. Okay, 7 pi over 4. a cosine would be positive. I picked that because the reference angle is the same as the one we had before, so it'd actually be a positive radical 2. And then when we do a minus 2 sine of 2x, we would have sine of 14 pi over 4, which would be the same thing as 7 pi over 2, which is a coterminal angle to just pi over 2. So there again, that would equal 1. So this would be root 2 minus 2 times 1. So we have a negative. Hang on, is that right? Looks like we have a negative value. Let me double check that. We have 2 cosine of 7 pi over 4 minus 2 times the sine of 2 times 7 pi over 4, so 7 pi over 2. And that is a positive. Okay, so I must have done something wrong there. So that's a positive. So it's increasing there again, and we have a min point right there. Okay, so there's a couple more examples of an application to a problem that involves trig functions and our chain rule again.